Comparing two populations with independent sample. To compare two populations using independent sample, we have only two tables. This table is for significant levels 0.05 2 tell or 0.05 1 tell, or 0.25 0.022.5% 1 tell, or 0.10 2 tell. That's it. We have only two tables. Actually, we can construct more tables, but we are going to use only these two tables in our exercises. But here we have an inconvenience because this table only could be used when my sample size are smaller than 10. In both cases, we have 10 for N2 and for N1, 10 here in both cases. When my sample size are bigger than 10, we need to use another procedure. And the distribution for our test statistic, the sum of all rank, will be normally distributed. This table gives value for the lower and the upper critical values for N1 and N2 less than or equal to 10. That is the mean of the sum. In this procedure, we are going to use always the first sample. This is the first sample and this is the second sample in our data. But we are going to use always the sum of the rank, not the sum of all of these values, the sum of its corresponding rank, always of the first sample. Let me tell you why these formulas are right. If we have, for example, this data, 1, 2, 3, 4, 5, doesn't matter what is the corresponding value, but these are the rank, only 5 numbers, and we can rank this number from the first to the 5th position. Then what is the mean of this? The mean could be obtained adding all of this. If we add, if we have 3 plus 3, 6 plus 4, 10 plus 5 is 15, divided by 5 observation, the mean is 3, is the value exactly in the middle. There is a formula to find 3. The formula to find the mean is adding the first one and the last one, 1 plus 5 divided by 2. And if we want to obtain the sum of all of this value, the sum is 15. The sum could be obtained multiplying the mean times the number of values. The sum of all of this value could be obtained multiplying the mean times 5. And in a general case, if we have n values, 1, 2, 3 until n, the mean of all of this value will be n plus 1 divided by 2. And the sum of all of this value will be the mean multiplied by n. Actually, the formula could be written in this way: n times n plus 1 divided by 2. If we have, as in this case, two samples, and we can order these two samples, then the first group is from 1, 2, 3 until n1, and the second sample, if we need to order them, must start in n1 plus 1, n1 plus 2 until n1 plus n2. In total, we have n1 plus n2 values, two samples, n1 in the first sample, n2 in the second sample. Then the mean of all of these numbers must be given by n1 plus n2 plus 1 divided by 2. If I want to obtain the sum of all of this value only, we need to multiply n1 times this mean. That is the expected value for the sum of the first group given here. And a statistician, they found the standard deviation of this, the distribution of this sum, the sum of the rank. Remember, rank, the standard deviation is given by this formula. If this is the mean and this is the standard deviation, we are going to use this value as our test statistic, the distribution of the sum of all of these rank, because when we order this value, the value of my first sample, in this case, the rank of this value, in this case, this is the first value, the minimum, this is the second one, the third one, and so on. But here we have a value that is in the 8th position, this in the 7th position. But it's possible that we have in this first sample rank number 13, rank number 10, whatever. We can combine, we can obtain this value in different ways. Then the sum of all of this rank, whatever is the combination, the sum of the rank, follow a normal distribution. The mean is given by this number and the standard deviation is given by this number. Then the C-score, because the distribution will be normal. The distribution of the sum of this value, this rank, no value, this rank, follow a normal distribution. This will be T1. The distribution of all T1 is normal. The mean will be given by this number and the standard deviation is given by this other number. If I obtain any T1, suppose this, if we are doing a right tail test, if we suspect that this value, this rank are bigger than the second one, then T1 fall here. We need a reference value. And if we suspect that these rank are smaller than this, then we expect a value on the left. But if we have no idea, then we have a two-tailed test. And always we need a reference point. We can obtain this reference point from alpha, and we need to find this Z alpha half or C alpha, depending if it's a right or a one tail or two tail. If it's a two tail, this is alpha half. If this is negative, then T could fall here, here, or here, depending where T falls. We make a decision, and that's it.